For those of you that want a long form video, well, you're in luck. You're going to get one today on this Panasonic DVD recorder. Enjoy.
So today we've got another DMR EH50 in for service, and this one here is totally dead. It's going to have the standard capacitors that probably need to be replaced in the power supply. These two and this one over here, more than likely. It looks like this one's already been replaced because it's been done the same way as the last one, where it was clipped out and a new one just tacked on. You see, that was very common because this capacitor here was a very common failure on these units, and that's the way that everybody fixed them. Every one of these that I've seen that cap has been replaced, it was done the same way because as I explained in the last video, you don't want to be taking out this main board unless you have to, because it's a large board. It goes all the way out to the front. To change it, you've got to remove the DVD drive, the hard drive, the bracket. You have to remove the SD card reader, and again, you don't want to disturb that battery. So it's imperative that you don't take the board out on these unless you have to. And that includes unplugging things like the SD board, if you don't have to unplug anything, because it's got power to it from that battery, and you can mess things up. You can change the hard drives generally without causing a problem, but you don't want to unplug other things unnecessarily, because it's a good chance you could corrupt the data. This one here, as I say, is totally dead. I don't know whether it's just the caps or whether we have a regulator problem on this one as well. I guess we could put a scope on this and see whether there's any oscillation. See if there's any voltages at all. So let's just plug the power supply in, power the unit up. We'll just check and see if there's any DC voltages anywhere. Because if there's no DC voltages on any of the rails, then we could have a failure over here on the regulator IC, which is what happened on mine. If you remember that one, the original one I did, the first DMR EH50. Actually, the first one I ever serviced was my own. But we'll take a look and see, first of all, whether there are any DC voltages present on any of the rails. Oops, on any of the rails. Let's try putting this in. So we do have DC. We have 12 volts, right? So we know that the oscillator's running, so no problem on the AC side. But the unit itself is not turning on. It's got a display on it now. It says please wait. Didn't have a display when I first looked at it. I think we probably have a voltage that's low. So let's repair this power supply. Turn it off and let the voltage drain out. For sure, there's going to be a couple caps in here for sure that need to be done. This one's not bulging yet, but the ESR is probably heading north on it, as is this one here. So let's pull the power supply out and check some of those caps that go bad, that are known trouble spots on these units that, as I say, fail repeatedly, right? And it doesn't matter what quality of capacitor you put in, it's going to fail again in a few years. And it's just because of the way that these power supplies operate, the frequency they operate at. They're very punishing to the actual capacitor itself. So it doesn't matter whether I put in a cheap one or a good quality cap. A few years down the road, it's going to need to be replaced again. And that's typically what happens with capacitors in general. You know, you'll see some people that will say, well, just go and change all of the caps. Well, yeah, you could do that. You could certainly change every one of them. You're wasting your money doing that, though, because not every one is going to fail. Especially in power supplies, there are key caps that are going to go bad every time. And just those key caps are going to be the ones that cause you problems. The other ones typically won't. If we want to make sure that this unit is discharged, I can measure the DC voltage across the main filter. We'll see it's down to 3 volts. So I don't have to worry about getting a shock on touching anything here. We can, if we want to make sure it's completely dead, I can short it out. But at 3 volts, it's completely discharged. As I was explaining, on DC, or, well, inverters, DC to DC converter, and that's what this is. It's a DC to DC converter. You see the incoming AC is rectified right here by the full wave bridge. Main filter capacitor that's used to operate the oscillator circuit, and IC 1150, which is this one here, which sometimes the connections go bad on them and it should be resoldered if it looks bad. They develop bad connections which can cause them to fail. Somebody's resoldered this transformer. But basically your AC is converted to DC. The DC is chopped up into a pulse width modulated, or in this case frequency modulated, because it's typically a 50-50 duty cycle, but they change the frequency. And and what that does is how they control the voltage on one of these power supplies is there's a feedback loop. The feedback loop is presented through this opto isolator. And basically there's an LED, and the LED will normally glow a certain brightness, and it's shining directly on a phototransistor. The brighter the LED shines will indicate the voltage. If the voltage goes higher, the LED gets brighter. If the voltage goes lower, the LED gets dimmer. And that affects the conduction of the phototransistor on the other side of the optical isolator, which in turn changes the frequency of the oscillator. And the key to regulating on these type of power supplies is to control the frequency. So the transformer itself over here is resonant at a certain frequency. 50 or 60 kilohertz is quite normal. And how you control the output voltage is you change the input frequency to affect how close the transformer is to its resonant frequency. At the resonant frequency, which is determined by the core size and number of windings, but typically it's the core size. At its resonant frequency, the transformer is at its highest efficiency. So these are really close to like 95-96% efficient at that frequency. As you move away from your resonant frequency, as you move either below the resonant frequency or above the resonant frequency, the efficiency falls off substantially. So the transformer becomes less efficient and the output voltage will drop. How these work is by changing the frequency to move the transformer closer to or further away from the resonant fundamental frequency of the transformer. In early Panasonic devices, they operated below the resonant frequency. So to increase your power, you brought the transformer closer to resonant frequency, and to decrease your power, you took the transformer lower in frequency, away from its resonant frequency. The problem that happened with those early switch mode power supplies in the early Panasonic VCRs that used them, like the PV13, I think it was the 1360, 1350 or 1360, when the oscillator, typically a little capacitor like this, dried out, cap in the oscillator dried out, it tended to cause the frequency to go up. And even though the optocoupler was full brightness, the LED was fully bright, and the phototransistor was in full conduction, because the capacitor dried out, the frequency was creeping higher and higher and higher. The voltage kept going higher. The feedback circuit was screaming, turn the voltage down. But because the cap had dried out, the voltage was creeping higher and higher, and the transformer was getting closer and closer to its resonant frequency. And the voltage was going up, 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 up. And eventually, something would blow, and it was typically every IC in the unit. I remember seeing a few units come in that had every IC was blown. It had a big hole burned on top of it, and of course the unit was right off. And then Panasonic started adding a Zener diode across the output rail, so that if the voltage went too high, the Zener diode would conduct and basically commit suicide and blow the power supply up. But at least it was better to blow out the transistor than it would be to blow up every IC in the actual circuit. The next year they changed the design and they shifted the frequency higher to go to the other side, and they went up in frequency instead of down. So go up in frequency, you get out of resonance. You go down in frequency, you get closer to resonance. So then what would happen as capacitors in the primary side started to dry up is the frequency would go up, but the effect of that was the voltage would drop, and once it get below a certain voltage, the unit would shut down. Now there's another problem with going to higher frequencies. The original switch mode power supplies were typically operating around 40 to 50 kilohertz. The newer ones were operating in the 60 to 70 kilohertz range. The downside to operating on higher frequencies was, well, you're rectifying it here in your diode. And typically the first capacitor off of that diode, there's two of them here in parallel, saw the highest ripple current. And it really was hard on the caps in the secondary. The higher the frequency, the more heat that gets produced inside the capacitor. That's why they went to 105 degrees Celsius caps. And it's an ongoing battle when you have these secondary caps right off the transformer, off of a half-full wave or half-wave rectifier, that they are going to fail. And it's only going to be the ones typically that are directly connected to a rectifier. So this one here is directly connected. This is a secondary one. It'll also go bad because when this one starts to go high ESR, this one starts to see more and more ripple. So they're both going to go bad, but typically it's only going to be the ones that are right off of the transformer, right off of a diode, are typically the ones that are going to fail. So we look back at this other one over here, or no, it's this one here, I think it was this one. You'll find that this one here is also going to go back to a diode right here. And any of the ones that are directly fed from a rectifier diode are going to be the ones that get damaged the easiest and will always fail. The other ones that are secondary filters, usually after a choke coil, not so much. I'm not saying they can't fail, but they generally don't, as a rule, cause the problems that the others do. Anyway, enough of my ramble about power supplies. Why you don't have to change every single cap to fix these things. Generally, you only have to change 2 or 3 and you'll get the unit going. Let's take these ones out. We'll measure them. Normally you can measure ESR in circuit, but when you've got 2 or more in parallel, the second one is going to affect your reading. So we're going to pull these ones out and measure them. And guarantee that that one's going to be bad, and so will that one. And most likely that one there will also require replacement. And probably only those 3, which is the same 3 that I replaced on the other one. Except for on that one, a couple of them were bulging. This one here, it's starting maybe a little bit. It's hard to tell, but this one here certainly isn't bulging at all. This one here, possibly. It looks like maybe. But anyway. The other thing to note, the ones that came out of the other one obviously weren't the original ones because they were 2200 microfarads, and if you remember, I replaced one with a 2200 and I replaced the other one with 1000, which got me to 3200. Well, look at these ones here. Right? They're 18 is all these ones are. And the other one I put 2200 and I put 2 1000. right? So I got up to 42, right? But this one here, if you look at this one here, these are 1800. So these ones are original on this one. The other one, they had been replaced, and they failed again, and they'll fail again down the road. It's just, that's just the way they are. It doesn't matter what brand you put in, they are going to fail, and it's something that repeatedly will happen, and it's more maintenance than anything else. Lead-free solder crap. We'll put some fresh tin on here just to make it flow a little easier. So let's look at this one cap that came out of this unit and see how this one looks. 0.02. Nothing wrong with this cap. How about this other one here? That one's 1.4. This one's bad. We'll change this one out. I'm going to put this original one back in because there's absolutely nothing wrong with this one. ESR on this is perfect. So there's no point. I could change it out, but there's no point. It hasn't started to fail, and it probably will last just as long as anything that I could put in there today. So we'll reinstall this one and move on to the next and find out how the other one looks. Well, I've got it. I'm also going to reflow the IC. I checked the ESR on this cap over here, and it's also very good. So this one's not bad, although it is one of the ones that causes trouble. But I'm going to check the ESR on the rest of these caps here and see if there's any others that are bad. It looks like so far I've just found the one, which was the one that was here. I'm just switching them around. I put this one back in on this position, and I'll put another one over here. But I'll check their ESR on the rest of the caps before doing that. So after measuring all the other caps, only the one that was bad was just the one was really bad, and the others are actually checking out okay. So we're going to put a couple 1000s in place of that 1800 that was bad, and we'll power this thing up and see whether anything else happens, or is there some other fault with this unit beyond these caps. Please wait. That's what's up on the screen. Another display that is pretty hard to see. All these ones were pretty bad. I don't hear the hard drive trying to spin up or anything on this one. So I'm curious, do we have both of our voltages for the hard drive? "12 volts and 5 volts. We do have both the voltages for the hard drive, but I don't hear the hard drive attempting to spin up. The drive has been removed on this one at one point. It's not screwed down. Screws are missing on this side anyway. Let's verify if the hard drive is bad. I just have a standard IDE drive. It's not the right drive. It's a computer drive. I want to see if it'll try an attempt to spin up, because this one's not even attempting to spin the drive up. The drive's been jumpered to the same configuration, which is cable select. Gonna plug in the power. Now obviously this thing is not going to boot up, so I just want to see if it spins up, because the bias on this is going to be wrong, and there's nothing on here. This is a computer drive, but if it attempts to spin the drive up, that'll tell me that the drive is defective. If it doesn't attempt to spin the drive up, then we got another problem. So power on. It says please wait. See if it tries to go into the self-test mode. See, no attempt to even start the drive. It should try to spin the drive up to read the drive. So it may be this. It may be on this board here, or on the main board. Power supply is good. I know that because I swapped it with the other one as well, and so we know the power supply is good. But no attempt to start the hard drive.
If you put the wrong hard drive in, because this one worked with specific drives, but if you put the wrong drive in, it will still spin the drive up. It just will not access it. It will give you a message on the screen telling you that the hard drive is not compatible. And I have done that on other units. So it should try to spin the drive no matter what, and it's not.
I know that somebody's been into this before, because you see the screws that hold the drive in place are loose, and two of them are missing. And this particular unit was, the guy that brought me this said this is one that he bought as a parts machine. So I don't know what's wrong with it, and at this point I'm going to write it off, as they've been swapping boards and stuff around on this and swapping parts around, so I have no idea where the problem is. It's very likely this little board here is where the fault is, more than likely. This is the interface board. Lift this out and just make sure it's seated properly. But this is the digital interface board for both the DVD writer and the hard drive. So obviously if there was a problem on this board, then it would stop everything from working. I just want to see if there's any pins that aren't seated properly. Like if someone's been swapping parts around, maybe one of the connectors isn't seated. Just some of my favorites on here. Surface mounted electrolytics. Wonder if one of those is causing the problem. Let's just measure this one here, 47 at 6. 14, that's a little high. That one's gone. Get in here and test some of these other caps. 0.8, that one's okay. That one appears to be open. That one appears to be open there, and how about this one over here? So this may be the problem. This may be the fault with this one. 0.8, that one's okay. So this 10 and this 47 both appear to be. Yeah, that one's open. We'll swap these caps out. That one. What was that one? 17. That's a 22. That one's also bad. And this one here is 15. That one's also bad. As you can see, my meter is pretty much zeroed out. So these four caps here, that one, and that one, are testing bad, and that certainly could cause this thing to not boot up. So let's remove this little 47 here first. Okay, got that one in place. I got a couple 22s over here. I think I got some 22s in this little pile of caps. A little kit. That's some low profile 22s. These ones are a little bit bigger. And one of these goes in negative this side. The one closest to me is negative to the right. Okay, it's got the 4 caps replaced on here. Get the please wait message again with the new caps on the board. Now one of those caps had been leaking, and it looks like the electrolytic has soaked into the board itself. So very likely the problem is this board here is gone. That's the logic board, the digital board that does your recording. It's got your MPEG compression chips and your Dolby decoding chips and so forth. Interfaces the DVD drive and the hard drive. And what happens when you power this unit up is it does a self-test on this board. And normally what happens when you power it up is it'll say please wait, and then it goes through the self-test. When it's going through the self-test, the hard drive will spin up. It'll check the hard drive for errors. It'll check the DVD drive for errors. And then once everything's passed, then the unit powers up. This is stuck in the please wait status, which is generally indicating that there's a failure on the digital board here. So at this point, I'm going to leave it and let the guy know that owns it. Again, this was his parts machine that he's bought for swapping boards and stuff. So I'm going to assume that this is the board here, that this was probably bad when he got it, but don't know anything about it history-wise. But I'm going to wash my hands of this one. So 1 out of 2 is fixed. I guess I'll have to leave it at that.